Hello dear students, welcome to Real Numbers Session 3. So we were dealing with exercise 1.1, finding the HCF LCF. Okay, so we will be continuing with the questions. So we will be starting with the fourth question, that is, they have given the HCF of two numbers to be 9. They are asking us to find the LCM of those two numbers. Okay, so we know that LCM into HCF is equal to the product of the two numbers. So LCM into HCF is equal to, the two numbers are 306 and 657. Okay, so product of those two. So we know the HCF, bring it to the denominator. So LCM is equal to 306 into 657 divided by the HCF. In place of HCF, substitute the value as 9. Upon further simplification, we get LCM as 22,338. Clear? Any doubts? Okay, let's move ahead further. So, this problem must be solved using the product of two numbers is equal to HCF into LCM rather than prime factorization method. That becomes a tedious process, isn't it? Yes. Next question. Check whether 6 to the power of L can end with the digit 0 for any natural number L. So here we will be using fundamental theorem of arithmetic. So 6 to the power of L can be written as a 2 into 3 the whole power L, which can be further written as a 2 to the power of L into 3 to the power of L. Yes? Okay. So for a digit, okay, to be ending with 0, it should be divisible by 5. So here the number isn't divisible by 5. So 5 is not a prime factor of 6 to the power of L. So there is no such natural number for 6 to the power of L to end with a digit 0. Okay, so this conclusion statement is important. Okay, yes. So in order to solve such problems, the concept used is, if a number should be ending with 0, it must be either divisible by 10 or it should be either divisible by 5. And the prime factorization of such numbers are unique. Okay, that is what our fundamental theorem of arithmetic tells us. Okay, very simple. Next question we have here is, they have given two expressions. Okay, upon solving those expressions, you get some number. We have to tell these numbers are composite. Okay, so the first expression we have here is 7 into 11 into 13 plus 13. So this is our first expression. When we take 13 common outside, we get 7 into 11 plus 1. So upon simplifying, we get 13 into 78. So here we know there are more than two factors. 13 into 78 is one among those factors. So therefore, this entire expression which simplifies to a number is basically a composite number. It's not a prime number. Okay? Yes. So next expression we have here is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So we can see 5 over here. We can see 5 over here. Take common. So we are taking 5. Upon simplifying, we will be getting as 5 into 1009. Okay, well, it's a composite number. Whether 5 is a prime number, 1009 is a composite or a prime number, we no need to check. But when it is multiplied, prime into prime is a composite. right? Prime into composite is a composite. Composite into composite is composite. When it is having more than two factors, then it is called as a composite number. So therefore, this entire expression which gives a number is a composite number. Clear? Any doubts? I suggest the students please do pause the videos and make running notes. Okay? Yes. So basically, the numbers are of two types. One is prime and a composite number. Prime number has only one two factors. So what are those two factors? Number one and the number itself. Whereas the composite number has factors other than one and itself. So above two examples are the uh, ones which tells us they are the composite numbers. So, well, at the end, you have to tell why they are composite because 1009 is a composite number with more than two factors. So, henceforth, it's a composite number. You have to conclude it. Okay? Yes. Next question will go. There is a circular path around a sports field. Solia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? After how many minutes will they meet again at the starting point? So, well, it can be observed that Ravi and Sonia do not take the same amount of time. So, Ravi takes lesser time than Sonia for completing one single round of the circular path. So, as they are going in the same direction, they will meet again at the same time when Ravi have completed one round of the circular path with respect to Sonia. So, when Sonia is one round, the Ravi completes 1.5 rounds. So they will be the first time, and which is the common multiple of the time they take will be one round. So LCM of 18 and 12 is what we are supposed to find. Common multiple. So what is the LCM? We find it out. 12 and 18, we'll write the prime factors. 18 can be written as 2 into 3 square. 12 can be written as 2 square into 3. Okay, so LCM of 12 and 18 is equal to the product of the prime factors raised to the highest exponents. So highest exponents is 3 square and 2 square. When you multiply, we get it as 36. So Ravi and Sonia will be together at the starting point after how many minutes? After 36 minutes. Clear? Any doubts? Okay. So let's find out a load point to remember how to solve this. So in order to solve word problems, the very first step which we have to do is interpreting the problem and identify what is need to be determined, what need to be found. Okay, the problem asks for simultaneous reoccurrence of events. So we need to find the LCM. Again and again, how many times it is happening, they are asking is. So we have to find the LCM. So the keyword for simultaneous reoccurrence of events is basically called as the LCM. At the end, do not forget to write the final answer. You have to write it as 36 minutes. Else, your answer becomes wrong. Okay, you will be given marks for it. So this was all about the first unit of the chapter, fundamental theorem of arithmetic. So hopefully you people learned it. Any doubts, you can clarify it. Okay, so we will be moving ahead to the next unit of the chapter, that is revisiting irrational and rational numbers. So we come across the other segment of the real numbers, rational and irrational. Okay, so as in the beginning we had told A real number is a combination of rational and irrational number. Well, now we will make it used over here. So what is a rational number? Any number which can be expressed in the form of P by Q, P upon Q form, and where Q is not equal to 0. Such a number is called as a rational number. What is an irrational number? Any number which cannot be expressed in the form of P upon Q is called as a irrational number. So, well, we have theorem 1.2 telling us let P be a number. Okay, P be a prime number basically. If that prime number divides A square, then it divides A also, where A is a positive integer. Okay, so this how is it implemented? We will see it in theorem 1.3. It is implemented in theorem 1.3. How? We'll see. So this is one of the standard type of questions, dear students. Okay, root 2 irrational, root 3 irrational, root 5 irrational, root 7 irrational, and some more questions which comes in the example. These are some standard questions which they should be asking from this chapter. So first we have been given that root 2 is a irrational number. So how to prove this root 2 is a rational number? We are choosing one method called as method of contradiction. So in this method of contradiction, what we will be doing is we will consider root 2 to be a rational number. So just opposite to it. If we are able to prove that our statement is wrong, our assumption is wrong, that means we are able to prove what the given statement, what is the given in the question is correct. If we are assuming things wrong, if we are able to prove our assumption is wrong, the alternate thing, if not this, that is correct. Okay, so let root 2 be a rational number. So if root 2 is a rational number, it can be expressed in the fractional form, that is a by b form, where a and b are the integers and b is not equal to 0. That is, your denominator is not equal to 0. Also, A and B are co-prime numbers. What do I mean by co-prime numbers? A and B has its HCF as 1. Okay, that I mean it as co-prime numbers. Now, I will be squaring on both sides. Once I square on both sides, what happens? Root 2 whole square is equal to A square by B square. Root and the square gets cancelled. So 2 is equal to A square by B square. So when I take b square onto the other side, 2b square is equal to a square. So b square is equal to a square by 2. Now, we can see this 2 is a prime number which is dividing the a square. Isn't it our theorem 1.2 which we discussed in the above slide? Yes. So 2 divides a square. Now, 2 divides a also using that theorem. Now, we'll take an assumption. We'll assume a value for a as 2c, where c is an integer. So, we have taken this as equation number 1. We will take this as equation number 2. So, by equation 1, we'll substitute 2c in equation 1. Wherever a is there, substitute it as 2c. 2b square is equal to 2c the whole square. So, 2b square is equal to 4 into c square. So b square will be 2c square. So c square is equal to b square by 2. So here 2 divides b square and 2 divides b. 2 is a common factor, right? You can see 2 is dividing both a and b. So 2 is dividing is a common factor for a and b. That means a and b are not co-primes. Our assumption is wrong. We have taken A and B to be co-prime numbers, right? So here our assumption is failed. So A and B has factors as its HCF other than 1. So 2 is its HCF over here. So it's not a co-prime number, which contradicts the fact that root 2 is a rational number. If root 2 was a rational number, A and B were supposed to be a co-prime number. So here that is not happening. So root 2 is not a rational number. So we can prove that root 2 is a rational number. So hence proved. So this is how we prove Root 2 is irrational by the method of contradiction. Okay, clear? Yes. So we will be going with example 5 in our next session. Okay? Till then, watch the video, pause, make notes, running notes. If any doubts, clarify it on live. If it is not possible, you can contact me on this number. Okay? Thank you. Have a nice